Salvete, sumus interpretis linguae Latinae. Hello, we are interpreters of Latin language. I am Susan Shin, and I'm a rising senior from Middlesex School in Concord, Massachusetts.
I'm Summer Joel, and I am a rising sophomore from Deerfield Academy in Massachusetts.
And I'm Zoe, and I'm a rising junior from Thrift School in California.
Have you ever taken a foreign language? Maybe you're taking Spanish, French, or Chinese. Well, I bet everyone in this room had a time when you wanted to check if what you translated is correct while you're doing homework at night or even traveling in a foreign country. For most spoken languages like Spanish, there are numerous accurate translation models online like Google Translate. However, that is not the case for Latin. We wanted to create a model for other classicists around the world like us. Our model is designed to process grammar and syntax to provide an accurate translation of Latin sentences to English without relying solely on statistics.
When we were creating this model, the primary concern was our data set. We realized that right away, the accuracy of the model would depend solely on the size of the data set and also on how accurate the entries were. So we decided to combat this by including 3 different types of Latin to English translations in our data set. So the first is a vocab list of roughly 12,000 nouns, adjectives, pronouns, adverbs, verbs, and conjunctions. And so a portion of these nouns, adjectives, and pronouns were actually fully declined, but the rest of them were only declined in the nominative and genitive singular place. And similarly for the 5 conjugations of verbs, only a portion of them were fully declined and the rest were just split into their participles. Also, our vocab words were translated with multiple synonyms in English, and this vocab list is very important to include because it's useful in translating words literally. So the second part of our training data set were 2,200 phrases and short sentences taken from common sayings in Latin, as well as textbook examples. So these are phrases that are usually 2 to 6 words, and they're useful because they have relatively simple grammatical structures, and they use words that are commonly found together in order to better teach the model. Finally, the last part of our data set was 1,000 complex Latin sentences taken from real classical texts by Caesar, Cicero, and Virgil. So these are longer and more complex sentences that have multiple phrases or clauses and are written in the classical style, which means that they can have more complicated grammar and the word order might be different. And these sentences are useful to include because they can translate full sentences given to our model and analyze more complex grammatical structures.
So when we are training the data set, we randomly shuffled the data we have, and we select 13,000 entries from them, among which 11,000 are used for the training data, and the remaining 2,000 are used for the validation data. Here, for the model, we use an encoder-decoder LSTM model, which is very classical for neural machine translation. And here we train it for 120 epochs. We have some demonstration of the result here. This column is the predicted result, and this column is the actual result. And as we can see, we are pretty good at predicting vocab and short phrases. They are either exactly the same or there are some kind of synonyms, like here, the old man and the senior. I also have another example here when we predicted a sentence. So here, the input sentence is Aeque hac quidem quaestio communis est omnium philosophorum, which literally means, and the subject of this inquiry is the common property of all philosophers. You can see that our own translation of it is pretty accurate, except it changed "and" to "moreover." And here we can see the literal translation of every single word, and it's pretty accurate. When I put this sentence into Google Translate, we can see that the translation is not wrong. It's a literal translation of what it is. And because Latin sentences include sentences in which the grammatical structure is kind of messed up because Lan doesn't really have a fixed grammatical structure. The places of the word can be reversible. So here the sentence is not really accurate. It doesn't really make sense in English. And this is a result of like most translations for Lan using PBMT, which literally translate the meaning of one word to another word. And this is why the result is kind of messed up in English. That's all we have. Thank you everyone for listening.